Hi everyone, in this video we are going to look at how to find the asymptotes. So what we have seen from our rational function behavior is that the two important as well as new things that we need to consider when we try to plot these functions is the existence of these things called asymptotes, and they can be horizontal or vertical. So we have that their behavior changes accordingly. So let's start with the simpler one, because this is kind of a computation that you've already done, which is finding the vertical asymptote. So vertical asymptote, right, that is basically you're trying to find the input, that is the x value, right, for which the output or the y value blows up, meaning it is plus or minus infinity. Now, typically that happens when there is a division by 0, because when you divide by a very small number, you get a very large output. So what we do is we factor the denominator and we set that equal to 0. Okay, so let's take the denominator. The denominator is 2x squared plus 3x minus 2. Any choice of factoring is okay. I'm going to split the middle term with 4 and negative 1. I get 2x, x plus 2 minus 1, x plus 2. Then I get 2x minus 1, x plus 2. Right? So if 2x minus 1 times x plus 2 is supposed to be 0, then we either have 2x minus 1 is 0 or x plus 2 is 0, which gives me x is 1/2 or x is negative 2. This means that, so there are two vertical asymptotes at x equals negative 2 and x equals 1/2. Okay, so which means that if my ultimate goal is to find this plot, right, I don't know much yet, but what I do know is at negative 2 there is an asymptote, and at 1/2 there is an asymptote. I completely missed the 1/2 mark there. Makes more sense to do that. So that's x equals 1/2 and x equals negative 2. Okay, so that's how you find the vertical asymptote. What about the horizontal asymptote? Now, what is the meaning of horizontal asymptote, right? It means you're analyzing the end behavior, which is what happens when your input gets large, infinitely large or infinitely small, right? So what happens is x goes to positive infinity or negative infinity. So you're basically asking if, does the output settle upon a particular fixed value, right? So you have two possibilities. As you increase in the input, either the output just shoots up, it can shoot down, or you have this intermediate where you can say that it kind of settles to a value. So if it does settle to a value, then that particular case would be called having a horizontal asymptote. Now, how do we do that? Let's use the same example. Let me copy that. So we have 3x squared minus 2x minus 1 over 2x squared plus 3x minus 2 plus 3x minus 2. Okay, so the goal is to understand what happens as x goes to infinity or x goes to negative infinity, saying it's a large positive or large negative number. Right? And then what happens to this? Now here we are going to use a trick here. The trick here is we're going to use what we know about 1 over x, 1 over x squared, etc. as x becomes a large number. What do we know? We know that 1 divided by a large number is almost 0, which means that 1 divided by the square of a large number is 1 over, say, an even larger number, which is even further closer to 0. So in order to use that, what I'm going to do is I'm going to say that I divide the numerator and the denominator by x squared. That is the highest x power. Okay, so I get 3x squared minus 2x minus 1 over x squared divided by 2x squared plus 3x minus 2 over x squared. This is valid again because dividing both numerator and denominator by the same number is essentially saying I'm dividing this fraction by 1, which leaves it unchanged. Now, this division can be split. So you have 3x squared over x squared minus 2x over x squared minus 1 over x squared, all divided by 2x squared over x squared plus 3x over x squared minus 2 over x squared. Now we cancel what we can, and x squared cancel, x squared cancel, 1x cancels the extra x, and 1x cancels the extra x there. And what we end up with is 3 minus 2 over x minus 1 over x squared, all divided by 2 plus 3 over x minus 2 over x squared. And now we use this trick. Now we say that as x becomes a large number, what happens? 2 over x, 1 over x squared, 3 over x, 2 over x squared, these become almost 0. So eventually you're only left with 3 minus 0 minus 0, 2 plus 0 minus 0. So you're left with 3 over 2. And what is that? This means that the output or the y value is 3 over 2 as x goes to infinity. So this is a horizontal asymptote. Okay, the fact that this is a horizontal asymptote can be derived by using this particular method. Which means now if I go back up here, I have an additional information I can throw in here. I can say that y equals 3 halves is a horizontal asymptote. Now we still have to do some analysis here about to fill this graph in, right? Because we still have this possibility that the function is here or it's here, right? Is it here and here? Is it here and followed by here and here? Is it here and here, or is it here? You know, so there's a bunch of possibilities that we need to first make sure we can or we have to check which of these can be eliminated before we make certain claims about what is going on, right? So that is something we are going to learn in the later videos. The point in this video is to understand how to find the horizontal and vertical asymptote. So we're going to summarize this so that each time you do that, that's something you can sort of consider. You can do it directly, right? So here's the summary. Is vertical is simple, right? you set denominator equal to 0 and solve for x. Horizontal is if, so let's say you have px over qx is what you're trying to work with, right? If the degree of px equals the degree of qx, right? For example, what we had here, it was degree 2 and degree 2, then the ratio of coefficient of the leading term is the horizontal asymptote. Okay, so over here, if you look at it, the ratio is 3:2. So 3 over 2, that's the horizontal asymptote. And it sort of makes sense. If you look at this process, every time you have the same degree, if you follow this process, what is going to happen is when you divide by that highest power term, the first terms in the numerator and denominator are going to become numbers, and the remaining terms are going to be of the form 1 over number, which is getting larger and larger, so that its contribution is now 0. So you will always be left with whatever the coefficient of the numerator's leading term is and whatever the coefficient of the denominator's leading term is, which is essentially telling you what is the output value this whole thing is getting closer and closer to as your input becomes larger, and which is nothing but the horizontal asymptote. So that gives us a direct way of determining where the horizontal asymptote is. Okay. Now, one last thing. Let's actually fill this graph in by doing some analysis. Okay. Now, like I said before, there are some possible configurations here which we have to consider, right? First of all, we're saying, like, is it this or is it that? It could be either one of them. So in order to understand that, we have to find something called intercepts. Okay. So actually, well, this video has gone on too long. So this video will just focus on finding the vertical and horizontal asymptotes using these methods. And the next video, we're going to see that, well, we need a little more information to plot this graph because, for example, we don't know which configuration gives us an intercept, right? So that's another piece of information which is very, very useful in order to plot these graphs. We will go over that in the next video. That's it for this video. Thank you.